What the heck is the internet? The internet is a place for finding pirated films, bad memes, drawings of Atkins, and Monty Python. But more importantly, the internet is a place for knowledge. This is what we are going to be covering today, so fasten your seatbelts kids, it's time to learn some computer science. The internet has DNS servers. That stands for domain name service, you cheeky scrublords. A domain is just the location you are trying to connect to, for example a website. So a domain name would be just like google.co.uk. A DNS server will basically convert a website URL, like mahu.co.uk, into an IP address. This is pretty goddamn useful, because it means you don't have to remember a bunch of numbers whenever you want to Google dank memes. A DNS server is not used as a proxy between your computer and the domain. It just gives you the IP registered to the domain you are trying to connect to. Then you receive the IP, and can attach the IP to the packets you are sending to the domain. Next we will cover WANs and LANs. LAN stands for local area network. This means a network of computers that are physically close to each other. This usually means within one site, a building, an office, or even just one room. A LAN allows computers to be connected on a very low latency, which is very useful for playing games. They also allow data to be shared on a central server, or sharing hardware such as printers. Advantages of LANs include not having to have a printer attached to every computer in an office, and easily sharing work within seconds. However, a LAN is not always an option. Sometimes a WAN is needed. This is a wide area network, and they are basically multiple LANs connected together remotely. This means a company can connect a building in London to a building in Sydney, which is thousands of miles away. Obviously these could not be directly connected together to form a LAN, since you would have to lay a cable from one side of the world to the other. In fact, the internet is a WAN, so we are making some goddamn progress here. Next we will do the TCP/IP stack. The TCP/IP stack consists of multiple layers, just like a Shrek. There are 4 in total, and they are called the application layer, the transport layer, the internet layer, and the network access layer. There is also the OSI model, which contains more layers, but is basically the same thing, just a little more specific. TCP stands for Transmission Control Protocol. And if you haven't guessed, that means it controls the sending of packets of data from one device on a network to another device. The device receiving the packet can be on the same network or a different one to the sending device. TCP converts the items to be sent into packets of data. It also ensures a packet actually reaches its destination, and if it doesn't it will either resend the packet or stop if a connection cannot be made. TCP also sends a confirmation back to the sender to let them know the packet has been received successfully. IP stands for Internet Protocol. This is in charge of giving each device on a network a unique identifier that it can be accessed by. The current version of IP being used right now is IPv4. This uses 32-bit addressing, which gives a total of 4,294,967,269 different addresses kek. But apparently, 4 billion different addresses soon will not be enough. So IPv6 has been developed. IPv6 uses 128-bit addressing, which allows a total number of 3.4 times 10 to the 38 unique addresses. An IP address is simply used to connect to devices on a network. What's next? How about some protocol layering? Protocol layering is actually really simple. It literally just means stacking multiple protocols on top of each other to form layers. Within a single layer of either the OSI or the TCP/IP model there are multiple protocols designed to perform a certain function. A protocol in general terms is a set list of rules of what to do in a certain situation. In computing, protocols set a list of rules on how computers communicate with each other, allowing almost universal compatibility. Finally, I'm almost done with you scrubs. Last topic is packet and circuit switching. A good example of circuit switching is using a telephone. When you use a telephone, you are connected to a line between you and the person you are calling. No one else can use this line while your call is still going. This is circuit switching. This works fine for telephones, but is not practical for use with the internet. Packet switching is used for the internet. This involves splitting data to be sent into small packets of data. Then these packets are sent in different directions, depending on what is the fastest or is the least busy. Your router determines the most optimal route to send a packet along in one instance and will send one packet that way. There are a few problems associated with this. First of all, the packets may not arrive in order, so they are given a header with a number attached so that they can be ordered correctly when received. Secondly, packets can get lost and may never get to their destination. To prevent this, packets are limited as to how many times they can hop. A hop simply means going from one router to another. This prevents packets from permanently bouncing from network to network and slowing them down. Finally, that's all folks. We are done and it only took about 6 minutes of your miserable lives. It took like 3 days of mine to make this, so you had better appreciate it. Please don't kill me, Bo Banks.